Okay, so last lesson we stopped at the line chart. And next we are going to talk about a histogram. A histogram is often used. Well, what's going on? It's often used to show the frequency of numerical data. I use these bins, and usually the y-axis represents the distribution of the frequency, and the x-axis represents the values, the numbers. For example, here. Here, if I generate some random numbers, then I can use the histogram to show the distribution of these data. And it's very easy. You just give it the numbers and then the values, and then you tell it how many bins you want. You don't want to have too many bins, and then they will be very you cannot see the overall trend, or it cannot be too few. Let's just see this example. Okay. So you see, this is just because this is just a random data, so I cannot see the find the characteristic of this distribution because it's really random. However, if it's from some real data, you should be able to find either it's symmetric or not symmetric, and see the this is a mode, right? This is a mode because it has the most number around 75. This is a mode, and then the median and also the spreadness. That means it has a wide range. And you see, if you goes to too many bins, here it has 20 bins. If you use too many bins, you cannot find the shape of a histogram. You have to find the shape. But I usually use 20 is often used the number for the number of bins. So that's the histogram. And there's another chart we often use for explaining the distribution of the data. That's a box plot. So for box plot, it doesn't show the frequency, hey, how many 70s are there, how many 80s there. It doesn't show that. Instead, it shows the 4 quantiles. The first quantile, median, and then the third quantile. These are important numbers. And below the first quantile minus 1.5 quantile, that is identified. It is usually identified as outliers. So box plot is really useful if you want to find the outliers. And also, oftentimes we use box plot to show the difference between 2 groups of data. And we'll use it very often when we go to the next chapter about data prediction. So, for example, like when you have to show that to box plots, let's okay? Or maybe this median is here, okay? The other median, there are two box plots like this. And then these two groups, their median is very different. There's a huge difference between these two medians. However, from the box plots, you can see the spreadness, because of the spreadness of the data is pretty same. So even the median is really different, is quite different. There may not be significant difference between these groups. As you see, the upper and the bottom line between these two groups, they are pretty same. Right? Or in another word, there could be two box plots. Their median or average, they are the same at the same level. However, for this, for these two box plots, so it's another group, okay, and their there's another group like this, okay, and its median is still here. Which group is higher? Obviously, this group is higher. The numbers in this group, the overall is higher than this group, because even though their median is the same, because the spreadness shows that this number in this box plot, it's much higher than this, even though they have the same median. So box plots are it's very helpful when you want to examine compare the two groups of data, right? And we'll use a lot in our later lesson about prediction. And scatter plot is often used to examine the relationship between two variables. There are two axes, X and Y, whether these dots shows the X and Y have a relationship or not. Sometimes there could be a linear relationship, and sometimes it may just scatter that has no relationship. And it's really easy to run this code as well. As you see, you just give it the X and give it the Y. And then this is the marker. You want the circle or you want a triangle, and that's a color. So it's very easy to draw a scatter plot. You practice along the way. When you come to this point, you will find it easy to write this code. So not going to show it here. So another technique I want to mention is sometimes we want to draw what they call a subplot, a plot with subplots, and how we draw this. So let's go over this step by step. Firstly, you want to use this function to add a subplot. So this figure means with this function, it returns two variable. One is called a figure. Figure means a kind of the canvas. This set up the whole canvas, okay, the figure. And the axis kind of means the subplots. So this axis set up the subplots in this figure. So let's do this step by step, okay? I'll still use this data, and I want to plot for each day, Monday, Tuesday to Friday. What we can do is to use this subplot function, and as I said, I need a few arguments. This one means the number of rows in this canvas. Here, I just need 2 rows and 3 columns, and that will have more than 5 plots, so Monday to Friday. So I'll use 2 to 3. And then shared X, share X means you use the same X and Y labels. So here you see, if it's not shared, it will have these labels at each plot, each subplot. But here they only use the one. So this is, and often this is true. And share Y. And next thing, I need to get these variables returned from this function. And the next thing you do is to set up each of the subplots. So as I said, this represents the canvas, the whole canvas of the plot, and this represents the subplot. So next, what I need to do is to set up each subplot. So what it does is so this one, if you see it, this one actually, I'm not sure if I can print it out. Okay, this one is actually a list or a series. Let me try see if I print this one. It may work. You see, this axis actually has a multiple plots, so it's not just one plot. Okay, so we need to set up each of them. This is the axis 0. If you call 0, then it takes this one, and 1, 2. Actually, it's not 0. It's actually 0, 1. It has a you can think it as a 2D NumPy array. So 0 means the row number, and 1, and then the next one is the column number. So if I want to set up this, then it's the axis 0, 0. And this one, I want to give it a bar plot. So, and the numbers for the bar plot should be the x-axis should be these names, and the y-axis should be this Monday value. So really just this one. Right? The Monday value is this one. And the bar plot, the code for the bar plot is the same as what we did. So I give it the x is the 0, the first column, and then the y is the second column, 1. And what else? I think that's all we need to give it. Yeah. Next up, we go over each. So yeah, help me to set up this second plot. How do we set up this second plot? So this should be
0, 1.
0, 1, yes. And then the x as the names. So that do we need to change that? Yeah, it's still the names. They share the exit. It should still be the names of the people. And then the y should be the y now. Monday, Tuesday. So it should be 2, yes. Yeah, actually we actually should be able to show it already. If we use show. And you see basic not the values are already there. So yeah, you don't have to like finish the whole plot to display it. You could show it in the middle, so you can make sure you're doing the correct thing. right? And then the rest is we just copy and paste this code to finish the rest of the plot. Any question here? I thought good. We all good. And oftentimes for subplots, you also need to set up the title for each subplot. So that said, that this means that the subplots, and this means the entire plot. So for the subplot, you could just add a title like what we did. 0 and the title as a Monday. Okay. It's the same. Okay. And see here, there's some
position for Tuesday.
What's the problem here?
Do you not change to 0-1 for Tuesday, the title? Instead of 0-0?
This one,
Tuesday?
yeah. Looks like there's some other errors. Text object is not callable. Yeah, this is correct. So okay, so actually it use another function set title instead of the title like here what we used here. Okay, so that's a problem here. Okay, makes it work. And the next thing, we need to set up the title for this whole plot as well. And what we need to quote here is which one we need to quote, which one represents the whole plot. That's it. Which variable represents the whole plot? Fig, yes. So you need to work on the fig, yes. And the fig, subtype. I forgot the function as well. And then the subtitle. That actually it should work. Title. Or maybe I'm wrong. So it doesn't work. I need this subtitle. It doesn't have this attribute title. Instead, you need to use subtitle. Is this the correct function? Yeah. Okay. So that help us to add the title for this entire canvas. Okay. So that's how we do the subplots for the data. Okay. It really depends on what you want to get from the data, and then you choose the appropriate format. What we learned: stacked plots, or grouped bar plots, or the swap. Okay. So this is the subplots. Okay. Here I included some extra information here. These are some other libraries we sometimes use, like Seaborn. Occasionally use it. And Plotly, you can use it to generate fancy plots like Matplot here. So you can compare if the data is like some records across the state, so then you can just Matplot. Just copy this code, use this code, refer to this code, and change the numbers. You will be able to use it. I don't want to go over it here. Okay. Watch out, this is a bar plot. Usually, bar plot is not good example actually. Usually, it's organized in a way, like the color is descending. Or let's explain it later here in the slide. Okay, so we have mentioned all those commonly used plot types and how to choose the right type. First, you need to know what question you are asking, what problem you are asking, whether it's you want to know the percentage of a different group, compare the percentage of a different group, then you choose pie chart, right? If not, you choose a regular bar plot. So really, you first need to know what you want to tell from your data, what the question you want to tell, and then you choose the right type of chart, and then you prepare the data. So that means that you have to clean the data, or maybe you have to do the data summarization, the pivot table before you generate the chart. Right? If it's a massive data, you need to do the pivot table first to summarize this before you do the chart. And then you can create the chart and format it, adjust the parameters, and to make it pretty. That's usually the steps for creating the chart. And here's an additional link to explain the different chart types. Okay, after you generate the chart, you have to communicate your result with your audience. You cannot say, "Hey, boss, the chart is here. I've finished my task," but you need to tell him what you have observed. So that's the section I included here, communicating your result effectively. And especially if you're writing a report alone, then you have to explain the results after the chart. Okay, so let's go over each chart and know how to explain the result effectively. Usually with a line chart, you want to highlight the trend, whether it's increasing or decreasing, and whether the degree is whether this growth is sharp or slow, and also the peak and the bottom. For example, in this chart, this is the chart for child sex ratio of child birth in India. So actually, you can get a lot of information from here. There's a bottom, and there's a peak, and there's this growth and decrease. So according to this, so the report here explained that here abortion was legalized in this year, and that's why this is a turning point here, and it climbed all the way to this year, right, 2015, and then it decreased. Why? There's another campaign called Save the Girls. So observing the data, and then you explain the result with your knowledge. Okay. You first you get to the numbers from this chart and this data, and then you use these numbers to explain the result, to tell your story. Okay, next thing is multiple line charts. So for multiple line charts, other than explain the trend of that line, you can also compare compare across the lines. For example, here, if we compare, you see this percentage of numbers who are not employed for pay. So here, if you compare these lines, As you see, the percentage of mothers who are not employed is decreasing, and both parents are not employed. It's increased a little bit also, and the percentage of some dads stay home increased 3%. So this the increase of this one is bigger than the other two lines. So refer to these links I've attached here when you are working on your homework and you need to explain your result. Okay. And the next one is bar chart. Okay. Bar chart, usually you summarize the difference across the group and the highest, lowest point and the significance between the differences. And usually you should organize your bar chart in a certain way. Maybe just by the names, or it may be organized from Monday to Friday, or like this one. If you have a horizontal bar chart, it's often organized in a descending order from the longest to the shortest, right? Don't do the bar chart. Hey, this longer, like what you call have no. You cannot generate anything. There is a like all kinds of lenses grouped together, not organized. So this is a nice way to organize this, either descending or ascending. So for example, here we can see that people who attending religious services and their reason for attending the in-person service. So yeah, the most people think it's a sense of a connection, fellowship, and then you see the second reason for attending. Okay, and all the way goes to the bottom. And this one, it's not put in the middle, although it's 17% because there's no answer. So they put it at the bottom. So that's a good way to organize this horizontal bar chart. So here, another reason why I want to set up an individual meeting for your project is you probably did it the right way, but maybe there are some space for improvement, and we want to discuss about that. Okay. Next is a grouped bar chart or stacked bar chart. So similar to multiple line chart, instead of looking at the single bar, you can compare the differences between across the bars. For example, this one is about people's opinion, like whether they think speak their mind freely online is more important, or feel welcome and safer is more important to them. And you can see teens, they think more of them think feeling welcome and safe online is more important compared to adults. And probably adults are more focused on, more confident and more focused on their task. Yeah, but overall, and more people think feeling welcome and safe is more important than speaking freely online. So you should compare horizontally and compare across vertically. Okay? It's stacked bar chart. Pie chart, it's a little bit different. So when you need to you can compare the different groups and the contribution of the different groups. And usually you tell your story from the largest piece and to the smallest. So this is a survey about teens say it's hard to give up social media. So that's the amount of time. Well, the amount of time they spent on media. Most of them, over 50% of teens think they are spending the right amount of time, while some think 36% think it's all right, and 8% very few people think too little. Right? Okay, so that's how you explain the data from. You just go from the largest piece to the smallest piece. Right? And the histogram. So for explaining the histogram, usually you highlight the center of the data, which means what is the highest being mean. That means the data has the most frequency, which means you use mathematical language, it means median or mean or mode. Histogram.
So which one?
This one, the highest being means median or mean or mode. Yes, mode, the most frequent one, has the most people. So this is like survival time. Some survival only a few days, maybe like less than 500 days, and some people they even survived after cancer 3,000 days. But here, this is the mode. Most people died within 500 days. Okay, so usually you highlight the mode, and then the median. The median probably goes around here. The median means half of the data is on the side and half of the data is on the other side, separated by the median, right? So this median is probably here or a little bit over here. And then you would tell the shape. The shape is either symmetric or asymmetric. It could be skewed right or skewed left. So in this map, in this picture, it's skewed. I think it's called, I believe it's called skewed left, or more data is on the left, called skewed left, and has a long tail on here. Skewed left means more data is like on the side smaller. Right? So so that's how we explain the shape, whether it's symmetric or not symmetric, and if not symmetric, how it's skewed. And also you need to explain what that skewness means. Well, that's this here in this picture, the skewness means okay, more people died within this certain period. Giving another example, if it's some it's a data of student score from 0 to 100. Okay, so this is the 0, and then this is the 100. The next game, and I have another data. This is 0, and this is 100. which group, which class has the better score?
One,
Why? Answer is correct. Your answer is correct.
it's just closer, the mean is closer to 100.
Yes, the mean is closer to 100, which means that more people more people have higher scores, and it's only a few outliers here. They are driving the mean down, driving the mean down. Okay, so that's how we usually explain the skewness. Okay. Now also the spread, yes, whether it's concentrated to the middle, like this one, it's very concentrated, or it's a wide spread, the range. Okay, explain the range of the data. And the next one is that you could observe some outliers, perhaps. So here, actually, having no outlier, these are also all connected, but sometimes there might be an outlier far away, like a small beam over here, then that means an outlier. Okay, the next one is the scatter plot. So scatter plot we use to explain the relationship between two variables, right? So first, we usually see whether they have usually you do this one first, okay? Whether they have a strong relationship or not. See, this one has say a moderately strong relationship or very strong relationship or no relationship at all, right? Copy. So in this plot, I believe there's a moderately strong relationship. They are all along this line. And then you explain whether it's a positive relationship or negative relationship. This is obviously positive when X grows, Y grows. And the third one, linear or curved relationship. This one is, I'll say it's kind of linear, right? A little bit curved at here, but more for a linear relationship. And sometimes this relationship, it could be like a few dots. I cannot draw on this picture, okay? It could be a linear relationship. Oh, no, it could be a curved scatter plot. So if it's a curved scatter plot, what does it mean? It means so if it's a curved scatter plot, for example, if the dots shows the relationship like this, then that means that the X and Y, what the relationship between X and Y using the math we learned. But if it's linear, a line, it's a Y equals AX plus B. It's linear, right? AX plus B. And if it's a curved like this, this means that
Say polynomial and it's got like a
yes,
square or something like that.
that's right. Yeah. That means ax square plus b if it's a curve, and if the curve turned at some point, then it's a higher polynomial. It could be means x cube plus x cube plus x square and plus x, right? So just means the degree could be higher than square. Okay, so you also, the third one you need to explain is to explain this is whether this a linear relationship or a curved relationship, and then you want to identify if there's any outlier. So sometimes there might be a dot on a corner, and that's obviously an outlier. And when you calculate the data, you should not include that. So for example, this one is the relationship between your body fat, and then the BMI. What is the BMI stand for? Is body mass index, right? Body mass index, yeah. So this shows that your fat level, body fat level, is closely related with your body mass index, and it also explains it curved slightly because it flattens out for higher BMI value. So even if your BMI increase, even if your BMI increase anymore, the percentage of body fat, it doesn't increase anymore because it reached the maximum amount. So as you see, it also explains that it should include squared term. It should be a polynomial relationship. Okay. I believe that concludes our lesson today, and so just work on this assignment first, because it goes over each step of data cleaning and then data visualization in this assignment. And in the project, you have to design these all by yourself. Follow the step, do the cleaning step by step, data cleaning step by step, and observing whether you have done it in a good job, or still there are some outliers or inconsistencies, and then do the plot. Okay, yeah, that's all. But you enjoy the project, and just let me know any questions.
Question, is the
Yeah.
project already posted or is?
I'll release it on Sunday.
Say it again?
On this weekend, I'll release
Okay.
it. All right, earlier than this weekend, yeah.
Okay. Hold on. What?
81.
I'll come outside. Which is.
Before you.
Yeah, I should know.
Oh, that's fine. I don't mind. Let's talk a few minutes.
All right, thank you. You know. Yeah. We are.
Look at that.
I just got one question, but I actually have one.
You got.